In this video, we're going to be talking about how to find the experimental value of g and the acceleration of an object rolling down a ramp. And we're going to assume that it's frictionless and that the rotational energy of the object is also insignificant. So this is basically a very similar version of Galileo's ramp experiment. And the way we're going to look at it is two different ways to potentially solve for g or a. Now, if we take a look at this object, it has the force of gravity pulling it straight down and the normal force pushing up perpendicular from the surface. Now, if it's frictionless, the normal force isn't that significant. So we're just going to focus on the force of gravity, which has a perpendicular component and a parallel component. In addition to that, we have an angle of the ramp, which we'll call theta, which also translates to this triangle as well. Now, we mostly care about this component right here, which we'll call FGX, because that's the parallel component that makes the ball accelerate down the ramp. Now, because that's the only force going parallel to the ramp, this is our net force. Okay, now if we do a little bit of trig, we have the opposite end and we have the hypotenuse side, which is mg. So we can say that the sine of theta equals the opposite end, which is our FGX, or our net force, over m times g. Now, in addition to that, we know with Newton's second law, if we take the sum of all forces along either of the axes or the net force, then that equals the mass times the acceleration. So with that being said, you can go ahead and make a little substitution and take that ma and then put it up here. Now from there, what it looks like is the sine of theta equal to m times a over mg. So then our mass is going to drop out. So whatever mass you use is not going to be significant. Now, if you want to solve for the experimental value of g, you can have the g and the sine of theta switch places if you just cross multiply them. And then also, if you want a formula for the a value, you can take that sine of theta and then multiply it back over. And there are your two formulas to find your experimental g value and your acceleration. Now, a lot of times this is done as a lab where you have to take some experimental values and you need to plug in an acceleration. So for this one, in order to find our g value, we would need to know theta, which is the angle of our ramp, and we also need to know a, which is our acceleration. So let's go ahead and clear a little room so we can talk about how to solve for those two. So if you wanted to solve for the acceleration, the most common experimental method you would use is you would use some sort of motion detector, and you would be taking a look at the velocity versus time graph. And then you would get some sort of slope that looks similar to this. And then once you highlight it and find the slope, the value of the slope is equal to your acceleration. And then that's the number you can plug in for your A. Now, when it comes to the theta, you can measure it a couple different ways. If you had a protractor, you can go ahead and find the angle of it that way. If you do not have a protractor, then what you need to do is use a little bit of trig and take a look at this height right here. We'll call that h. And take a look at this horizontal distance in the bottom. We'll call that dx. And then if you want to mathematically solve for the angle, you can say the inverse tangent of h over dx is equal to your angle, because the opposite and the adjacent side are tangent. And if you want to find the angle, you always use the inverse tangent. So if you measure these two heights and converted them into meters and then divided them by one another and found the inverse tangent of it, that would give you your theta value. And then that would allow you to get your experimental value for g. Now, if you want to solve for your acceleration, You can find the theta the same way by doing a little bit of trig or measuring it directly with the protractor. And then most likely if you're solving for a, then you would just assume g is going to be 9.8 as it usually is. Anyways, those are the two methods to solve for our unknown variables are g equals a over sine theta and a equals g times sine theta. So I hope that was helpful to you. Thank you for watching and listening.